Welcome to Curie Electronics. Today we are going to learn about optical sensors. So before getting into the theory and what are the types of sensors available, let's see a practical sensor. So this board you could see here, this is a commercially available low cost optical sensor. So this black one is a sensor. One is a transmitter and receiver. It's a light sensor. Now it has got three input pins, that is plus 5 volt we have to apply, ground, and the output. I have connected a pull-up resistor and LED to show you. So now if I block with a paper, see the LED turns on. That is because it is staying at high. Initially the output is high, but later on it is changing to low. When the output goes low, the LED turns on. See this? See the light LED? It is not so visible. It is like coming as a bright light. Already we have seen the working of a simple sensor used for digital optical encoder. Now we will see what is a digital optical encoder and what are the main types. So what is a digital optical encoder? A digital optical encoder is a device that converts a linear or rotary motion into sequence of digital pulses. The output of a digital optical encoder is a sequence of pulses. Sequence of pulses means what? We will have a digital high, low, high, low. The output, this is the output of a optical encoder. So this can be this pulse duration may vary depend on the type of encoder. That is, it can be a absolute encoder or incremental encoder that will come across. First let me write the definition of the optical encoder. A digital optical encoder is a device that converts a linear or rotary motion into a sequence of digital pulses. A digital optical encoder is a device that converts a linear or rotary motion into a sequence of digital pulses. What do you mean by that? See, linear motion means it is linear from left to right or right to left or vertical or horizontal, any kind of linear motion. It can be a vertical, downward, in any angle also. But in a rotary motion means we'll have a clockwise or anti-clockwise rotation.
So when this rotation or linear motion happens, we will get a sequence of output digital pulses from a optical encoder. Now, see, I have already shown you the video of simple optical sensor. Here also we are using the similar type of optical sensor. This is only the difference is that this sensor is mounted in a vertical position, which I have shown you is horizontal position. Now, see, this is a rotary wheel. In the rotary wheel, see, this is the shaft. This will connect to the motor. This part will go to the motor. And when it rotates, we will get a number of pulses. See here, this is actually what type of it is, a incremental type encoder. Incremental type encoder. How do I say it is a incremental type encoder? Because see here, this is a marked position. This is the reference position. So the incremental type of encoder, we have a reference position. Based on that reference position, we will come to know what is the exact position of this rotation or rotating wheel or shaft wheel. Okay. See here, slots are there. So it will open the sensor, also close the sensor. What is there on the sensor? I told you there is a transmitter as well as receiver. When there is no object between the path between the transmitter and receiver, it is closed. When there is some object, that is a metal part come across the beam, this is open. So it will generate. See, this is an incremental type sensor. So it should generate a same frequency or time period pulses. It is not going to be vary. Okay, it is only the drawing where time drawing is a slight difference is there. Otherwise, it is going to give you the same. Okay, from the number of pulses, we will come to know what is the exact position of this wheel. Now, simply I'll tell you what are the types of digital encoders. How do we classify them? Digital optical encoder. How we collect digital optical encoder. How can we classify them? See, these are actually digital type, not analog type. Okay, that already we know. So this digital optical encoder can be classified as linear encoder. Linear encoder. This is the simplest one. Then we have a rotary encoder. Under rotary encoder, we have two types. Which are the two types? One I already told you, that is the incremental encoder, which will have a reference position. Incremental encoder. The other one is the absolute encoder. Absolute encoder. Here there is no reference position. This will give the absolute position of the wheel. But it is similar to incremental encoder, but this will give a different sequence of digital code. Now, what is an absolute encoder? Absolute encoder. Absolute encoder. In absolute encoder, what happens? In absolute encoder, it will give a unique digital word correspond to each position. For each position of the rotary wheel position, it will give a unique word. Unique digital word. It is not a same sequence of digital pulses. It's a unique digital word. How do you get that? See, assume that you have a we have a similar kind of wheel. I'm just drawing it, and here we have slots. See, this slot length is so much, but next position slot length may be small, and again it may be too small, then it will be more. It is going to be more like this. See, different lengths are there for these slots. So these different length help us to produce. See, this may be still longer. These different length of slots help make a different period of pulses, so that we can get a unique word, unique digital word, unique digital word. So that is how this absolute position encoder works. The incremental, already you understood what it is with the diagram itself. We have seen that is the incremental type, incremental encoder. In incremental encoder, there's a reference is there, a reference. Based on that reference only, we are calculating the position of this wheel, rotating wheel. It is simple also, okay? In incremental encoder, digital pulses are produced as the shaft. When the shaft rotates, these digital pulses are produced. And the main thing is that it has got a reference. So from the number of pulses, we can understand, or we can identify, or we can program it to identify what is the location. So this is a simple video to understand the optical encoder. I hope you understood. Any doubt, you can ask in the comment section. If you like the video, please share with your friends and don't forget to hit the like button.